Okay, so we're learning the second half of 3-4. You guys did long division, and long division, the reason why we have to learn it is because you can divide, you can have any polynomial as a divisor with long division. With synthetic division, which we're going to learn now, you can only have a first degree binomial. So what does binomial mean? Two. So a first degree binomial means the variable is to what degree? First. First degree. First degree binomial. So synthetic division is a method used for dividing linear expressions, which would be first degree, correct?
You want to write this down?
That's up to you. Okay. You need to know you can only do this with a first degree binomial or a linear expression. Linear would be first degree, correct? The leading coefficient of the divisor is 1, and A is a 0 of the divisor. Now, this statement right here does not always apply. Your book says it has to be 1, and it doesn't. You just have to deal with fractions if it's not. I don't think you want to write down the steps because I want you to watch the steps so you can look at them, but do not write them all down. Does that make sense? Okay, so steps for synthetic division. You write the problem in terms of only zeros of the divisor. So that means you take the divisor right here, because remember yesterday we talked about the divisor, the dividend, and the quotient. Yes?
Like when we do our test, are we going to do, like on our test, are we going to be doing it both ways?
Yes.
Okay.
Yes. Okay, so we find the 0. Well, how do you find the 0 of anything? You set it equal to what? 0. So we set this equal to 0 and solve. Well, wouldn't we add 3 over? Yes. And we get what?
X equals 3.
We get x equals 3. So we're going to use the 3. You write the dividend in terms of only the whats. What are those? Coefficients. You see there is still a placeholder. And what's that placeholder? 0. And then we go through a process of bringing down the first term, multiplying, combining, multiplying, combining, multiplying, combining, answer. Okay? So it's really quick. I have to make sure I go slowly because I like to go fast with it. And you will go very fast with it, but when we're learning, I will go slow. Okay, so we have 2x cubed minus 7x squared minus 4 divided by x minus 3. Now, I could use long division if I would like to. I can do that. But the divisor, is it not a first degree binomial? It is. So since it is, I can use the synthetic method, the synthetic division method, which is quicker.
Miss Mick,
Yes.
what do you mean by that? If there's like a 2 in front of the x, you can't do it that way?
You still can, and I will show you. The book you will have fractions. Okay, so the first thing I have to do is set the divisor equal to what? 0. So x equals what? 3. So I have 3. And we're going to just make like an upside down division bar. Because that's what you do.
So a really long L?
Sure. On its side.
How long does it need to be?
As long as it needs. You can extend it later. Okay, so we're going to write down the coefficients. Remember to fill in any gaps. Remember, any polynomial has to be in order also, correct? Okay, so I have 3, so my coefficient is 2. My next coefficient is? Nope. -7. Do not write them too close together, especially for you sloppy people. Okay, do I have an x to the first? Nope, so I have to put 0 and then -4. So I'm going to write some things on this first time that I'm never going to write again. So you bring down the 2 every time. You bring down the leading coefficient every single time. Got me?
Yeah.
Okay. And then 3 times 2 is what? 6. So -7 plus 6. -1. Then 3 times what? -1. It's -3. 0 and -3 is -3. 3 times -3. So -9. So -4. -9 is. Okay. So, yes, sir.
So for the first one, you just drop the first number?
Every time.
Okay.
The leading coefficient drops down every single time.
I'm already confused.
We've only done one problem. Take a breath. Okay. This last number is always your remainder.
What if you didn't have a remainder?
Then it's 0.
So can you show us how, like, are we gonna go over how that can be a 0 or like?
If we got -4 and +4, it'd be 0.
Oh, okay.
It will happen sometime today, but if that is 0, your remainder is 0.
Okay.
Okay. So this was x cubed, yes? Divided by x. Well, x cubed divided by x is what? X squared. Every single time your answer is going to be 1 degree less than your dividend.
Well, that makes sense because that's
'Cause
how our answers are always
Right.
supposed to work out.
Well, sometimes when we did long division, sometimes it went down 2.
Yeah.
But since we're doing it with only a first degree, we can only knock it down by what? 1. And we can do this multiple times. Okay? So we have the solution is x minus 3, because that's what we started with, right? Times 2x to the what? Second minus x minus 3 minus 13.
Wait,
What, Jane?
That was so much simpler.
That's not the answer.
That's the answer.
Forget how to do this.
You subtract everyone.
Okay, we're going to do it again. You guys have done one example. Open your brains.
I can't.
Okay, so I have 3x cubed minus 5x plus 10 divided by x minus 1. Again, I could do long division, but do I have to? No, because this is a first degree binomial, I can use synthetic division. So I set this equal to what? 0, and I get x equals 1. So 1 comes out here, and what do I put in the top row?
3.
I put the coefficients, so I put 3, 0. Why do I put 0, Cadence? There's no x squared, -5, and 10.
Wait. Oh, wait. Never mind.
I bring down the 3.
Yes.
1 times 3
3.
is 3. 0 and 3 is
3.
3. 1 times 3,
Is 3.
-5. 3 is -2. 1 times -2, -2.
8.
And I get 8.
Huh? How'd you get 3 out of negative?
1 times 3. 1 times 3.
Would it be 3
What is
times
that?
1?
Is that a 10?
Well, what's 1 times 3? What's 3 times 1?
Miss Meg, I'm ready for my homework. I'm so excited.
Are you sure?
I don't
Okay,
know why I like
so
that.
my answer is x minus 1.
Parentheses, 3x squared plus 3x minus 2, parentheses, plus 8.
I agree.
Okay?
Skill.
Why are we multiplying it by 3?
Because you take this number times this number.
What number?
One.
What number?
This number every time. So 1, there's a 3 here, yes? 1 times 3 is 3. 0 and 3 is 3. 1 times 3 is -2.
Sorry, I had to do it.
Focus, Kyson. Focus. 1 times -2.
Oh, so
you kind of do it.
You go here. What happens is you go here, 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 here.
Okay, I kind of get it.
Okay.
So you do that, and then you multiply it by the number.
Yeah, just
Four.
give it a second.
I'm gonna go.
Keep it. Bro.
Okay. Ready for another one?
No.
Yes.
No.
Okay. We need to know some things. Remainder theorem. Okay, we talked about where the remainder is. Where's the remainder show every time?
The last.
The last one. Now, this is awesome, guys. The remainder theorem states that if the polynomial p of x, that's just the name of the polynomial. P stands for what? Polynomial. Is divided by x minus a. The remainder r stands for what?
Remainder.
Remainder is p of a. So that means this right here would be, oh, hate it how it jumps. This right here would be x equals a, correct? So what this says is if I put a into the polynomial for every single x and work out all the math, I just get what my remainder is when I synthetically divide. That's what that says. So when I come back here to what we just did, open up for me. No. Why does it keep jumping? Maybe I took too long. Oh, I wrote, so it won't do it. Sorry. If I go back to what I just did, I could plug in 1 and get what we got our remainder. But I don't want to do that. Isn't synthetic division really quick?
Yeah.
Yeah? And once you get the hang of it, it's going to be really quick. So let's do it again and see what it works. Okay, so I'm dividing x cubed plus 10x squared plus 29x plus 24 divided by x plus 5. Want to use long division?
No.
No. And it's going to say use the remainder theorem. So we have to set this equal to 0.
-5.
So x equals -5. Guys, if they tell you divide and x equals -5, do you have to set that equal to 0?
Yeah. Wait, what?
No, if they say x equaled -5 in the problem, no, they already did it for you, correct?
Yeah, but if it's
But if it's x plus 5, you have to set it equal to 0, okay? Because sometimes they will just say use synthetic division with
Wait,
x
does
equals
this-
7.
Does this work with like the 3 numbers?
No. Your divisor has to be linear binomial.
Why is it -5?
Because you have to subtract 5 over,
Oh.
right? Okay, so -5, what goes in?
To the box? 1, 10, 0.
Do I need a 0?
Oh, wait, never mind. I see the 29 and x. So then 29 and then 24.
And then 24. So I bring my 1 down. So 1 times -5 is
-5,
combine
5.
-5 times 5.
-25. 4.
Combine -5 times 4.
20.
Combine
4.
4. So what this remainder theorem says, if I took p of -5 and plugged -5 into all these, my answer would be what? 4. So let's test it out. Ready? So I'm plugging -5 into here. So I got -5 cubed, right? Plus 10 times -5 squared plus 29 times -5 plus 4, right? So,
Plus 24.
what?
Plus 24.
Oh,
You want us to write this?
I don't care. So this 5 cubes 125, right? Right? So I have -125. 5 squared would be 25 times 10 is 250. And that would be a negative. 5 times 9 is 5, carry a 4, 14. And then plus 24. Okay, still doing just the math, right? We were done with long division, or short, synthetic division a long time ago, weren't we? Okay, so I've negative 125 and 250 would be 125, wouldn't it? Yes? And then, bless you. And if I combine 145 and 24 would be negative 21. And I think I get what? I get 4. So, do you want to use synthetic division or do you want to plug it in? Synthetic division. So, the remainder theorem says when I divide it, my remainder is my what? Answer. That's what it says. And it's going to tell you in the directions, it's going to say, use the remainder theorem to evaluate the function for 6. Okay? Your test is going to say that. And when you walk up to me and say, what's the remainder theorem? I'm going to say, because do you need to know what the remainder theorem is?
So you should.
Yes.
So we should write that whole problem down. You're saying.
Well, I assumed you wrote this problem down. This was just the check. Well, we're doing another one, so don't go.
Change it so I can write down the remainder theorem definition.
Change what? The remainder theorem definition's right there.
Yeah, I was asking for you to not change it.
Okay, well, we're doing the next example. I would assumed you already had the definition written down.
No, I was working on that.
You guys do the next one on your own. How about that?
I don't even know how to do the synthetic method.
We'll try it. It's really rather quick.
Hard.
Yeah. When does it change?
Why is it negative 2?
Because you have to set it equal to 0 and solve.
No.
How do you get the 12? What do you do?
It's
I always
right
get
from the
lost.
problem.
No, like I know that I got to right here, but I get lost right here.
You're not doing the problem. Like you didn't do this
I
one.
did do the
No, look. This one goes here.
But that one is there.
No, it isn't. It's above
On
the
my
line.
paper.
Look, it needs to be below the line. It is not there.
Okay, whatever.
It's not. Okay, then what did you do after you brought in the 1?
Well, it's on my whole paper says something. You do 2 times negative 2 times 8. Which
No, you do negative 2 times 1. Which is negative 2.
There you go.
So do you move that down too?
Now you combine. What is 8 minus 2?
6.
6. Now you do negative 2 times 6. Your multiplication answers go above the line. Your combining answers go below the
Oh, I
line.
got it.
And that's 0.
Sorry, did I say that loud?
Matthew, stop.
Yeah, give him a detention now.
So if I plug in negative 2, I get what, guys?
5.
5. Synthetic division is not a difficult process, but there's only one way to do it. Does that make sense? You can't make up your own rules. You can't say, "Ooh, I'm going to put it here, or I'm going to add this or subtract that." You have to do exactly what it says. Okay?
Matt said it's gonna get short.
I'm ready for my homework.
No, it's not.
He said 2 problems.
Okay, the next thing we have is wrong direction.
I think you went the wrong
The last thing we have is the factor theorem.
way.
There's another theorem.
Yep, but it's really easy, guys. The factor theorem says if the remainder is 0, then x minus a is a factor. It means I could have factored it, and I'd have no 0. It means it's an x-intercept. Aren't factors x-intercept?
You said that on the first day.
Yes, on the first day. I said, oh, it's a factor. Obviously, if I divide 25 by 5, I get 0. Like, I don't get a remainder, correct? 5 is a factor of 25, yes? If I divide 25 by 4, do I get a remainder? Why? Because 4 is not a factor of 25. Same thing, just with polynomials. So if my remainder is 0, that tells me that the binomial is a factor of my polynomial. That's all it tells me. So the question could be, is it a factor? Well, I don't know. Divide it. If the remainder is 0, the answer is what? Yes. If the remainder is not a 0, the answer is what? No. That's it. That's all the remainder theorem or the factor theorem says. Not a hard thing. Basically the same as the remainder theorem, isn't it? Because if I plugged it in, that means I'd get what at the end anyway? 0. Because it is a factor, it's an x-intercept.
Is it trying to say on that, or is the semicolon saying divide? Or what's the semicolon?
No, it says check whether x minus a is a factor of p of x. So that's just, this is p of x, and this is x minus a. It's just dividing the two. Like, separating the two. So if I'm checking if it's a factor, my remainder has to be what if it is a factor? 0. If it's not 0, then it's not a factor. And it says, so first thing we do is what?
Make x minus 6 equal to 0.
Okay, so x equals 6. So 6, what goes on top?
1. Negative 8. 16. Negative 23. 6. Negative.
Yes, negative 6.
Can you not go anywhere until I get this right?
Okay, I'm not going anywhere anyway. You guys are doing it.
I haven't been paying attention.
You're just doing synthetic division. The same thing we've done since we started notes. We are not doing anything different. I'm just telling you what the remainder means.
This is so much easier. This way is so much easier.
Yeah, but it doesn't always work. That's the
I'm good at
problem.
it.
It doesn't.
Why not?
Because it doesn't. Because you're not always dividing by a binomial.
Same, because I can't do the other
There's
one.
more than 3 numbers on your, whatever you call it. You can't do it.
Right, if your divisor is more than a first degree binomial, you cannot use this. Now, if your divisor could be factored into 2 binomials, you could just do this twice. But if you can't factor it into 2 binomials, then you can't do it.
Combine.
So long division works every single time, where synthetic division does not work every single time. If you get the first one done, go to the second one.
Decent, I don't like it.
Hold up. Yes.
And that's your work, guys. There's no other work. That's it.
Wait, Tony used to know.
What does our homework do if we do it over the weekend on Sunday?
Yeah. Well, Sunday sometime at Saturday at midnight, because Sunday I do it. I don't. Sometime in the afternoon I grade it.
Because I really don't want to do this tonight.
I would, then I wouldn't forget it. What do I have to remember to put on the second one?
Zeros.
A 0, right?
Yeah.
This assignment really shouldn't take you very long, should it?
Oh,
I have
budget
plans
wrong.
tonight and I want to go take a
Only
nap.
if you have to do the remainder.
Ding that.
Okay, I will tell you guys on your first assignment, remember I said all long division? And some of your directions said do synthetic division. So now you need to go back and do those problems with synthetic division. And you should get what? The same answer, shouldn't you? Okay.
Oh, no.
316.
Thank you.
Thank, this class goes so slow.
I can't. 3,
Today actually won't be
9.
fast.
8.
Yeah, 'cause
So the first one is the second one? No.
I said no.
Okay? That's all you got to do. But the second, so honestly, I'm going to go back. This is the remainder theorem, right? I mean, this is the factor theorem. The remainder theorem says that P of 6 is what then? 0, because that's the remainder. And P of negative 3 on the second one is what? Negative 21.
Wait.
Okay?
Huh?
She brought the remainder theorem back into what we were doing.
The remainder theorem and factor theorem are exactly the same thing. You're looking at the remainder, yes? It's a factor if it's 0.
Why don't I have yes and no in my elements?
You should not have yes or no on anything but these two.
I said why don't I if they're the same thing?
Because you perform them the same, your remainder tells you two different things. This right here is the remainder theorem. It says if I plug in 6, my answer will be 0. This gave me a remainder of 0, so that says that x minus 6 is a factor.
Oh,
It's because
now I
Okay.
get it. I thought you were plugging.
Any other questions before I go? Okay, and I'm sure that's it. Yep. Your assignment should go.